Good evening, everyone. I'm Melanie Mead from SoFo, and I'd just like to welcome everyone and ask that you please turn your video and audio off for now, as soon as everyone gets connected. And welcome to tonight's presentation, co-sponsored by SoFo, the South Fork Natural History Museum, and the Hamptons Observatory.
Hi, Joe.
You ready for me?
Not everybody's in yet. We'll give
Okay.
them another. There's a couple people still waiting to come in.
Will you
Okay.
be able to put in some of the people who are on the waiting list, do you think? I have some friends hoping to get in to see Joe's presentation.
They're welcome to try. We're not full. Not everyone has actually connected, so they're welcome to try.
Thanks.
Just a couple more people in the waiting room right now. I think everyone's in. Okay, you can use speaker view, everyone, and then you should be able to see the speakers. Okay, Susan, I think we're ready.
Okay, great. Well, welcome everyone to another one of Hamptons Observatory's edutainment talks, intended to entertain you while learning about our night sky, a cultural and spiritual inspiration for everyone at every age. First, thanks to Donna McCormick, our director, for arranging this talk in association with the South Fork Natural History Museum in Bridgehampton. I'm Susan Harder, the New York State representative of the International Dark Sky Association, and we help protect our view of the night sky from excessive, unshielded, and unnecessary night lighting. I'm on the board of the Hamptons Observatory, which is dedicated to providing these talks and star parties when we're able to get together again throughout the Hamptons, dependent only on your contributions. Before I introduce our speaker tonight, just a reminder that the next talk is by Dr. Hessinger, entitled The European Space Agency, Its Programs and Plans. That's on June 21st at 2. Easy to sign up on the website. Joe Rao, our speaker tonight, on the night of shooting stars, is an astronomer's astronomer who is a child, as many of us were, introduced to astronomy and eclipses by a family member from his grandfather. He has had a long and varied career in astronomy, penning numerous articles and lecturing on astronomy at the Hayden Planetarium in New York. He's even guided tours on cruise ships of night sky phenomena. I have found that astronomers are educators at heart, and we are privileged to hear from him tonight, so enjoy.
Well, thank you very much, Susan, and a very, very pleasant good evening to all of you. It is a very great pleasure to speak to such an organization such as the Hamptons Observatory. And tonight I would want to talk to all of you about something which I am hoping, crossing my fingers, that will come to pass a week from tonight. And on top of everything else, we also have to hope for the weather to cooperate. I was, for many years, a broadcast meteorologist, and I always had to explain when I was on television, I don't control it. I'm just the messenger. So if it turns out that it'll be unsettled next week, please don't blame me. Anyway, this is a PowerPoint presentation, and I'm going to set this up now for all of you to be able to see this on your screen. This is the amazing thing that you're talking to somebody who only a couple of years ago was still giving slide presentations using a Kodak ectographic projector. And now here I am in cyberspace doing talks for many, many people, not just in the local area, but all around the, well, just a couple of weeks ago, I did a talk for the Astronomical League of the Philippines, for goodness sake. So anyway, here we are tonight. This talk is based upon an article which I wrote for Sky and Telescope magazine. It's in the May issue. So if you could still find that, maybe at a bookstore or at a magazine stand, you can get the full details as to what I'm going to talk about this evening over a 6-page article, again, in S&T. Now, the story begins actually almost exactly 92 years ago. The gentleman you see on the left is Arnold Schwachmann, and the gentleman you see on the right is Arno. I haven't met very many Arnos in my life. Arno Wachmann. These were the dynamic duo astronomers at the Hamburg Observatory in Germany back in the late 20s and early 30s. And on March 2nd, 1930, they discovered a comet. But it wasn't unusual for these two, because they seem to have discovered a number of different sky objects, everything from asteroids, a nova. This was their third comet discovery. They would discover 4 in total. So since this was number 3 for them, they referred to this as Comet Schwachmann-Wachmann 3. From here on, I'm not going to say Schwachmann-Wachmann 3. I'm going to use a little bit of shorthand here and simply refer to it as SW3. So when SW3 was discovered in early May 2nd, 1930, observations were quickly collected from all parts of the world, and then they were able to use that to develop an orbit. And the orbit of this comet showed that it was a relatively short period object. It would return to the sun's vicinity every 5.5 years. But more importantly, right after it was discovered and right after the orbit was calculated, the orbit showed that on May 31st, 1930, this comet, SW3, was only going to pass 5,735,000 some odd miles away from the Earth. Now, when a comet comes that close to the Earth, usually one of two things happens. Either the comet puts on a spectacular show, or at the very least, puts on an interesting type of show. And over the last 40 years, if you've been in astronomy, into the hobby as long as I have, you may remember that we did indeed have 2 comets which came rather close to the Earth. The first was the interesting situation. That was 39 years ago, May 10th, 1983, Comet Iris-Araki-Alcock. That was a tiny comet which streaked closer to us than any other known comet in modern history, save for one back in 1770. There was a comet by the name of Lexell in 1770 that came within 1.5 million miles of the Earth. This comet, Iris-Araki-Alcock, came within 2.9 million miles of the Earth. Very close. It was a small comet, though. It did not put on a great show. As you can see in the photograph here from Newsday, it looked mostly like a ball, a fuzzy ball. And in fact, the ball was about the equivalent in brightness of Polaris, the North Star. But it whizzed across the sky from one end of the sky to the other over a span of 3 or 4 days. Now, if you're into astronomy and you looked at this through a telescope, you could actually see this comet moving against the background stars. In fact, a friend of mine said he likened the movement of the comet in the telescope view that he had to the minute hand of a clock. I'm sure if you look carefully at a minute hand of a clock, you could see that ever so slowly it is moving along. That's how this comet seemingly was moving in large telescopes relative to the background stars. So it was an interesting comet. An interesting comet in the fact that, again, it moved very quickly. Not a spectacular sight, but one that, well, as you can see, even the news media made a big deal about. And then 13 years later, in June, actually it was in March, this was in the June issue of Sky and Telescope, but in March of 1996, we had Hyakutake, a comet that was discovered by a Japanese observer, Hyakutake, and this comet came within 9 million miles of the Earth, a bit further away than Iris-Araki-Alcock, but it was a bigger comet, and it was intrinsically a brighter comet, more volatile material, brighter in appearance. It did indeed get quite bright. 9 million miles from the Earth at its closest, and on the night when it did pass close to the Earth, a good friend of mine, in fact, he was the best man at my wedding, Sam Storch, longtime member of the Astronomical Society of Long Island. Sam and we lived out on Long Island at the time. I lived in Levittown. Sam lived in North Merrick. And I said to Sam, you know, why don't we do something different? Instead of trying to observe this thing from here on Long Island, let's go to some place where it's really dark. And I knew of a place 2 hours north of New York, Hopewell Junction in Dutchess County. It was a nice little residential community. I said, I'll pick you up in my minivan and we'll travel up to Hopewell Junction to see this comet. And we did. And it was about 1:30 in the morning. We got to the to a local street on in Hopewell Junction. We both got out of my minivan, looked up at a comet whose brightness, it was right next to Polaris, the North Star, shining at 0 magnitude, as bright as any of the brightest stars in the sky, and a long, albeit faint, gaseous, bluish tail, which stretched across the sky from our vantage point for over half the sky, 40 degrees in length. And we just stood out there and stood for about a half a minute, didn't say a word. And then finally I turned to Sam and I said, well, this is something you don't see every day or every night of the year, and it's true. Comets like Hyakutake are few and far between, coming along maybe once every 20 or 30 years. But it was a spectacular comet, in part because it came very close to the Earth. Now here's the most interesting picture of all of this comet. It was taken from 29th Street and Avenue of the Americas in Midtown Manhattan. The person who took this picture, 2 o'clock in the morning, aimed his camera up toward the upper spire. Of course, you recognize the Empire State Building here. And right next to the Empire State Building, there is Comet Hyakutake. Of course, you couldn't see the tail. I said it was a faint gaseous tail, and this is Midtown Manhattan, but it was still enough to cut through the light pollution, and you were able to dimly see it next to the spire of the Empire State Building. That was remarkable. That was amazing. But anyway, that gives you an idea of what can happen when a comet comes very close to the Earth, like SW3 was coming in May of 1930. Alas, unfortunately, SW3 was not the biggest comet in the world. In fact, it was a puny little comet. The nucleus, the gaseous, the icy, irregular chunk of material that went into the making of this comet was only about a mile across. Halley's comet was a good 10 miles across. Comet Hale-Bopp was about 20 to 25 miles across. Those are big comets. Those are bright comets. But SW3, Schwackman-Wachmann 3, not so much. In fact, in order to see it, even when it was closest to the Earth, less than 6 million miles away, you needed a good pair of binoculars and a good idea of where to look in the sky to train those binoculars, or at the very least, a telescope. So not spectacular, and for the general public, not really all that interesting. But a comet is a comet, this one coming very close to the Earth, and so observatories around the world were aiming their instruments skyward to try to get a view of it. Here you see a view of the Yerkes Observatory 40-inch refracting telescope, still the biggest refracting telescope in the world. And on the staff of the Yerkes Observatory back in the 20s and 30s was a gentleman by the name of George Van Beesbroek. Van Beesbroek was an immigrant from Belgium who came to the United States. Here he is, you can see, looking at the eyepiece of the Yerkes refracting telescope. And Van Beesbroek, also known to his close friends as Van B. Van B was very much interested in the small members of the solar system, meteoroids, asteroids, and comets. Oh, he loved looking at comets. And so he had especially had an interest in looking at SW3 when it passed less than 6 million miles from the Earth in 1930, May of 1930, May 31st. And there you see, wouldn't it be great if you had access to a telescope like this? I mean, many of us in the hobby, we have what we call Dobsonian telescopes. I have a 10-inch Dobsonian reflecting telescope. That's wonderful to have a telescope that size. And I know people, there's somebody here on Long Island, maybe some of you know the name John Vogt. John Vogt has made a 32-inch Dobsonian reflecting telescope. That is a big telescope. But can you imagine, on any clear night of the year, since you're on the staff of the observatory, having access to the biggest refracting telescope in the world? That's what George Van Beesbroek had at his disposal. And he looked at it, he looked at the comet, he took photographs of it. This is not, by the way, 10 feet. No, the comet was not 10 feet across. The comet actually, 2 weeks before it made its closest approach to the Earth, measured 10 arc minutes in diameter. This was approximately 20 arc minutes wide. So the comet, 2 weeks from its perigee, or its closest approach to the Earth, appeared about 2/3 the size, the apparent size, the apparent width of a full moon. And on the night when the comet was closest, Van B, looking through that big 40-inch refracting telescope, looked at the nucleus and described it as a spindle-shaped star-like object. He may have been the very first to actually see the actual nucleus of a comet using that big telescope. So if you were into astronomy, this was a very, very interesting thing. Again, for the general public, not so much. And then after 1930, when the comet swirled back out into space, Schwarzmann-Wachmann 3 was MIA, missing in action, for about a half a century. Now, these are the dates when the comet passed perihelion, when the comet passed closest to the sun. Yet, on all these occasions, nobody was able to see the comet. Nobody was able to find it. All of these dates, all of these times, we actually recently were able to calculate backwards to get these dates. But none of these dates we were able to find or see where the comet was. In 1979, it briefly made an appearance, but then it was lost again in 1985. Why? Why was it so difficult to keep track of the comet? Well, number one, I already told you, it was a tiny comet, a small comet, a putative comet, which really didn't have very much going for it. You needed a good pair of binoculars at the very least, even when it was close to us, and a telescope certainly, and you had a good idea where it was. But another reason why it was missing in action for so long was because of this big guy. This is the biggest planet in the solar system. This is the planet Jupiter. Every now and then I'll pause to take a sip of Poland spring water, so pardon me if I just pause for a few seconds here. But Jupiter is the biggest planet in the solar system, 11 times bigger than the Earth, 1,300 times more massive than our planet. And Jupiter has done something very interesting. There are a number of tiny comets, just like SW3 out there. And whenever they pass close to Jupiter, Jupiter said, hey, where are you going? Grabbed onto that tiny little comet and put it in a short period orbit, which may be anywhere from 5 or 10 or 12 years, but an orbit nonetheless, trapping the comet somewhere in between the orbit of Mars and Jupiter. Now here is a view of the orbit of Mars. Here's the Earth. Here's Mars. Here's Jupiter. And there is an estimated 400 comets, tiny little comets, that have been captured by Jupiter. And Jupiter has placed them in these small orbits. And one of the members of this family of comets, the Jupiter family of comets, is Comet SW3. And therein lies the problem. When the comet passes close to Jupiter, Jupiter says, hey, where are you going? And pulls the comet and takes it off course and puts it in a slightly different orbit. Well, if we had an orbit calculated for the comet, and we said, okay, we're going to look for the comet SW3 tonight, you're looking and you don't find it, where'd it go? Probably what happened was Jupiter, using its great gravitational pull, pulled the comet a bit off course and put it in a different part of the sky. So you're looking in one part of the sky, the comet is in another part of the sky, and it's a dim comet. So that's probably why for all those years, 50 years, the comet was missing. Again, after 1930, we didn't pick up on it again until 1979. We lost it again in 1985. Then in 1990, the comet came near enough to the Earth, within about 30 million miles, to make it conspicuous enough and visible long enough for us to get a good handle, a good fix on both the orbit of the comet, and also we were able to get a good view of it. Again, probably the best view of it since the discovery year of 1930. And this is 1990. So best view in about 60 some odd years. Now, here is where the story begins to get interesting, really interesting. It's 1995. We know that the comet is going to come to perihelion, its closest approach to the sun, in late September of 1995. And in its advance, we're watching it with telescopes and with other instruments. This instrument that you see here is not a big fence. This is the Nankai radio telescope located on the grounds of the Paris Observatory in France. And the most interesting thing began happening in early September. This particular comet began to show an increase in gaseous emissions. In other words, we know that when the comet gets close to the sun heats up the comet. It boils off some of those frozen gases, causes a coma or a hazy head, if you will, surrounding the nucleus. And that happens time after time after time when the comet passes by the sun. But in this particular case, astronomers began to notice that a number of the gaseous chemicals were venting off of the comet at a much greater amount than before. One of them, in fact, the hydroxyl radical, I don't know how many of you remember your high school chemistry, the hydroxyl radical was spiking almost to the point where it was practically, well, not quite, but almost the same as Halley's Comet. Now we're talking about a comet much, much, much bigger than SW3, and yet it's suddenly boiling off all of these emissions at a rapid rate of, or amount. And now the comet was also starting to get bright. Now, at this particular point in time, only the biggest of telescopes could track it. This was around when the comet was like 12th or 13th magnitude. You'd need a pretty big telescope and a pretty dark sky to capture it, either with a camera or even to see it visually. The comet was suddenly, during September and into October of 1995, getting much brighter. Not 13th or 12th magnitude, but 10th magnitude, 8th magnitude, 7th. Now the comet was becoming bright enough so that you'd be able to see it quite easily with a good telescope or even a small telescope. So the Central Bureau for Astronomical Telegrams at the International Astronomical Union sent out a special, what we call ephemeris. All of these numbers here, this gives you the position of the comet in the sky. So if you have a star atlas and you plot these positions out, right ascension and declination on the atlas, you can tell night by night, week by week, where the comet would be and what constellation and what stars that comet was passing by to help you find it. But they added something. In addition to the ephemeris, they pointed this out. The Bureau has received numerous reports from observers worldwide of independent discoveries of this comet, which has continued its remarkable outburst in brightness. And indeed, when you looked up into the sky on this particular night in question, let's say it's October, let's say it's the early part of October, okay? And you're gonna spend, it's gonna be an all-nighter for you. You got your telescope, your binoculars, your camera, you're all set, and you got your list of all the objects, maybe messier objects, maybe a planet or two, maybe you're just gonna be out there with your binoculars and scan the Milky Way. Now the sky gets dark. And as it's getting dark and you look over into the western sky, you see something that looks out of place. You say, what is that? What is that? I don't recognize that. Looks like a fuzzy patch of light. So you get your binoculars and you look at it and you say, oh my goodness, that looks like a comet. And now you bring your telescope and put on it, that is a comet. What's a comet doing out there? I mean, you read your latest edition of Astronomy Magazine or Sky and Telescope, and it didn't say anything about a comet in October of 1995 in the western sky after sunset. And then you grab your iPad, or maybe in 1995, I don't think that they were around back then, but if there was such a thing as an iPhone, maybe you checked your iPhone out. You went on the internet and checked. You say, what is this? Is there something supposed to be out there? And then it suddenly hits you. It suddenly hits you. Oh my goodness, that's a new comet. I just discovered a new comet. And if you're the first 3 people to stake your claim and notify the Central Bureau for Astronomical Telegrams in Massachusetts about this, that comet belongs to you. You get to name that comet. Put your name on that comet. And it doesn't even cost you a cent, unlike some of these charlatan agencies that say you can name a star for X number of dollars. No, you can't do that. No, that's not going to work. But if you find a new object like a comet, and you're among the first 3 to find it, your name will be tagged onto that, and then it will forever be known as your comet. I'm still waiting to find my own comet, Comet Rao. I know a good friend of mine, Don Macklotz, who I'm going to see next week. He's discovered 12 comets, for goodness sake. Congratulations to Don. But I've yet to find one. I probably will never find one because of the way the skies are here. But here in October of 95, there was a new comet, and that's why the Bureau said numerous. How many must they have gotten? How many phone calls? How many emails? For goodness, how many telegrams must have poured into the Central Bureau to say, I've discovered a comet. But then the Bureau had to say, no, you didn't discover a comet. No, this is an old comet. This is Comet Schwackman-Wachmann 3. Hold on! How could that be? Well, the darn comet in 1930 was literally right next to the Earth. Less than 6 million miles, and we couldn't see it, even with our unaided eye. We needed binoculars. We needed. I'm looking at this right now. It's not a spectacular, brilliant, but it's visible plainly to the eye. And yet, this object was far, far away from the Earth. In fact, it was so far away that it was about 122 million miles away. Now, for some reason, which I don't know why, I'm not able to move my. All of a sudden, something has gone wrong, and I'm unable to move my screen. So what I'm going to do right now is I'm going to stop sharing for just a moment here. Then I'm going to go back to sharing my screen. Let's see if this works. Sometimes you have to give this a good kick. Why is this not working? All right, I'll try this again. We'll try this again here. I'm going to try this. I'm sharing it. Well, this is something new, folks. This has never happened before, and I've given this talk numerous times, but all of a sudden now, I have an inability here to move my screen, and I don't know why that is. So let me stop one more time. I know it's a little bit unorthodox. It's unorthodox for me, but maybe, Susan, are you still on here?
This is Melanie, Joe. I don't have a real suggestion.
Okay, well, what I'm gonna suggest is that what I'm gonna do is I'm gonna bounce out. I'm gonna leave for just a moment.
Right. Try to
and
reconnect.
then I will come back. And when you see me come back, then you can log me on, and hopefully that'll rectify the problem. And I apologize.
Okay.
I apologize to everybody. I'm just going to leave for a moment. I'll be right back.
It happens. It happens sometimes.
As they used to say, as Johnny Carson used to say, we'll be right back.
We'll have a brief commercial.
They say talk amongst yourselves.
Okay, I'm letting Joe back in, everybody.
Okay, can you hear me?
I can. You're back, and you should.
Okay, now I'm gonna try. I'll try sharing.
Yeah, I just remade you the co-host, so try now.
Okay, here we go. Cross your fingers, everybody. Oh, here we go. Start that. You know, maybe the reason why this is happening is I've done this talk so many times in recent weeks that it's just tired. Okay, now let's try this. There you go. All right. Oh boy, technology, folks, technology. All right, so where was I? So the comet SW3, as we go back now, it's almost like one of those tales like to be continued next week. The comet SW3 was 122 million miles from the Earth. How is it possible that this comet is gotten so bright to be able to be seen with the unaided eye when back in 1930 it was literally like right next to the Earth and you couldn't see it without a good telescope? How is that possible? That was very weird. In fact, one of the foremost comet hunters in Australia, actually, and that was a gentleman by the name of Terry Lovejoy, wrote, It looked like a mini Halley, a miniature Halley's Comet. Its coma, that's the head that surrounds the nucleus, displaying a striking parabolic outline. Its tail was so intense in its first half degree that the ghostly glow was evident even through horizon haze. So, even when the comet was down close to the horizon, in the muck, so to speak, in the haze that always seems to hang out near the horizon, you still were able to see a good half degree of the tail. This was weird. How could this possibly be? Well, we began to realize what happened in the days and weeks to follow. People looking with good telescopes noticed that the head of the comet looked bloated, if you will. And then all of a sudden, in early December of 1995, boom! No, not one, not two, not three, but four. Four nuclei were now visible. The comet had broke into four separate parts. And as a result of that, as a result of suddenly the gaseous emissions increasing in September and the brightness suddenly increasing in October, the reason the brightness was increasing was because the comet, there was probably a tremendous expulsion, if you will, of dust. When we cracked the comet open, all of this dusty material, all of this material came flying out of the comet. And dust is a very, very good reflector of sunlight. That's probably why the comet jumped up in brightness by a factor. Well, the comet was 25 times further out in space than it was when it was close to us in 1930, and yet the comet ended up 400 times brighter than predicted. Pretty amazing. In 2001, the comet, or may I say the comets, came back. Three big fragments were quite evident. But in 2006, that was exciting. In 2006, the comets were passing or would be passing within only about 7 million miles of the Earth. And now, not only do we have observatories here on the Earth, we also have observatories out in space. The Hubble Space Telescope and the Spitzer Space Telescope. Wow! So we have telescopes now in space that are able to look out into space and get a really good view of these fragments, these comet fragments. And now there were so many of them. By 2006, we were numbering them by using letters of the alphabet. Fragment A, fragment B, C, D, F, G, R, S, T, U. There were a lot of fragments out there. And with the Hubble Space Telescope, we got a view of three of them. Here they are. Here's fragment B, and fragment G, and fragment R. But if we zoomed in, if the Hubble zoomed in on one of the fragments, we ended up seeing fragments of a fragment. The fragments themselves, for goodness sake, were breaking up into smaller pieces and smaller parts. This was quite amazing. And now, after the Hubble was done with it, we handed it off to the Spitzer Space Telescope with its infrared camera. That's why the comet here looks kind of reddish-orange in color. But look, here's one big fragment here. Here's a teeny tiny fragment here, and another tiny fragment, and here, and there's a bigger fragment here, another one here, 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 here. And notice, if you will, along the comet's path, you see the comet's path is almost delineated in space by comet dust. This thing was literally disintegrating, breaking up right before our very eyes. In fact, over 60 pieces, 60 fragments were counted between the Hubble Space Telescope and the Spitzer Space Telescope. Now here's the orbit of the comet. This is the orbit. Again, it goes around the sun every 5.5 years. Comet Schwackman-Bachmann 3 or SW3. Notice right around here, the comet orbit is very close to, and this is near the outer rim or the outer part of its orbit, what we call aphelion. It was near Jupiter. Now, if Jupiter is nearby when the comet was passing through this sector of space, that's when Jupiter said, hey, come over here, and pulled on the comet and pulled it this way or pushed it that way. And you know, nobody really knows why the comet broke into all those fragments, why it broke initially into four big pieces. But what probably happened is that every time the comet passed near Jupiter and Jupiter pulled on it or pushed on it and pulled it this way and that way, you know, that's a lot of pressure on a tiny little body like that. And now, when the comet was coming around to its closest point to the sun and getting heated up to its maximum amount, between that and all those times it had interactions with Jupiter, the comet, if it were able to talk, probably would say, I can't take it anymore, and finally just fractured and broke apart into all those pieces. So that's one idea, one theory of what might have happened and why the comet broke in 1995. But notice, if you will, as we go around the orbit of the comet and as it comes down, sliding down here, it comes to this section right here. This is the orbit of the Earth. This is us going around the sun. And that's the orbit of the comet. And my goodness, the orbit of the comet and the orbit of the Earth are very close, right about here. And so the question suddenly began circulating. Is it possible, maybe, that the material that broke off of the comet when it split apart, is it possible that maybe sometime down the road the Earth might actually interact with that material and we might get a brand new meteor shower out of this? And people began to think, maybe. And you know what? There has been a precedence to this. Yeah, it's happened before. A very famous precedent in the 1800s. Here's a picture of Comet Biela. Now, Biela's comet was discovered by yet another German, Wilhelm von Biela, in 1826. Well, in 1842, just like Comet SW3, Comet Biela split, not into four, but into two pieces, so that in 1846, people looking into the sky with their telescopes saw a double comet, twin comets. And in 1852, the comet came back. It had about a 6-year period. And the comet came back. And again, we saw double. We saw twin comets. But then in 1858, we looked and didn't see anything. No comet. 1865, what happened? No comet. And so finally astronomers said, well, you know what probably happened. The comet split. We saw it for a couple of occasions as twins, but then after 1852, probably the comet just completely disintegrated. And I guess we're never going to hear from Comet Biela again. Well, guess what? Biela left its calling card in November of 1872. On a night in November, the 27th of November in 1872, when the Earth, in its orbit, crossed the path of the now deceased Comet Biela, we didn't see a comet, but boy, oh boy, did we see a meteor shower. Oh, and depending upon who you asked, and there were a number of observers who looked skyward on that night, and this caught everybody by surprise. Nobody was expecting this. This was an unheralded event. But depending upon who you asked, meteors seemed to fall at the rate of 3,000 to maybe as many as 10,000 per hour. Can you imagine seeing a celestial pyrotechnic display as this? That was the remnants, the pulverized remains of the once twin comet Biela. And so now people today are asking, is it possible that we might see a repeat of something like this with Comet SW3, the comet which broke into four pieces, the comet that has an orbit similar to Biela, coming very close to the Earth? Could we possibly hope to see a repeat of something like this in our sky? And that was the big question. Well, actually, this was not the first time it was considered. In 1930, when the comet was very close to the Earth, a Japanese astronomer said maybe we might see a meteor shower out of this. And in fact, one Japanese observer said, yes, I saw a meteor shower out of this. I did see a meteor shower from Comet SW3. On the night of June 9th and 10th in 1930, I saw meteors at the rate of 60 to 70 per hour. That's a pretty darn good amount. I mean, the famous Perseid meteor shower in August, which I'm sure all of you have seen at one time or another, that meteor shower produces about 60 or 70 or 80 per hour. So this was a meteor shower similar to the Perseids, right? Well, maybe not. In doing my research about this, I kind of drew some questions about this particular sighting of a meteor shower. One of which was that the meteors that were reported in this meteor shower were supposedly no brighter than 4th magnitude, and many were 5th and 6th magnitude. Now, if you know anything about astronomy, if you know anything about numerology, for example, magnitudes, the smaller the number, the brighter the object. So if you see a 1st magnitude object, That's a bright object. That's among the brightest stars in the sky. But if you see something that's magnitude 5 or 6, that's right at the threshold of naked eye visibility. That's just at the point where you would not perhaps need binoculars to see a star, but it's oh so very dim and faint. And this one Japanese fellow said he was seeing all of these meteors magnitude 4, 5, 6, very, very dim. Well, the head of the observatory in Japan, the Nissan Observatory, said, well, this person is known to have very sensitive eyesight. Okay, I can go for that, but wait a minute. Not only did he see these meteors, these faint meteors, he saw them on the night when there was a full moon. Come on. Full moon? 6th magnitude and 5th magnitude meteors? How could you see something that dim with so bright a light in the sky? And not only that, the gentleman who claimed to have seen the meteors, he said, oh, by the way, while the moon was out and I was seeing all these meteors, I saw a ring around the moon, a halo around the moon. The only time you could see a halo is when there are high, thin clouds in the sky. That's even worse. That's more of a handicap almost than the moon itself. So I honestly do not believe that this gentleman from Japan in 1930 on the night of the 9th and 10th in June actually saw a meteor shower. Maybe he was trying to make a name for himself. Because I also know that many well-known and very veteran meteor watchers all over the world, in the United States, in the United Kingdom, all over, were looking for a meteor shower on this night and saw nothing. And this one gentleman in Japan claimed to have seen it. So I would tend to doubt that there was a meteor shower that night. But how about now? How about in the future? How about this year? Now, all the ejected particles, regardless of size and unless perturbed, stay closely confined to the plane of the comet's orbit, at least until in time the stream degrades and drifts apart. Gravitational perturbations by the planets are a major factor in shifting and breaking up a meteor stream. Tracking all of these influences, in fact, is what a meteor shower and tracking it and forecasting one is all about. So the comet is like a cosmic litter bug. It goes around the sun, heats up, and it releases along its orbit all of these bits and pieces. And when we manage to track through that debris, we see a meteor shower. Now, if I mention a meteor shower to most people, this is probably what they think. And this is from, oh dear me. Remember this show in 1960s, Lost in Space? This TV show single-handedly set astronomy back 100 years. No, this is not what a meteor shower is. No, you don't get these giant boulders crashing into the Earth during a meteor shower. No. In the case of most of the annual meteor showers, the majority of visible meteors are caused by particles generally ranging in size from small pebbles to sand grains, and they weigh less than 1 or 2 grams. So, is it possible that we may see a meteor shower from Comet SW3? Back in 2005, 3 Canadian astronomers, Paul Weigert, Peter Brown, and Helen Shinge, wrote a technical paper about this. They're from the University of Western Ontario in London, Ontario, Canada. But they enlisted the aid of this guy right here, this gentleman, Jeremy Vaubollon. Jeremy Vaubollon is probably one of the foremost experts in meteor prediction, meteor shower prediction, because 20 years ago, he developed, using a supercomputer, a sophisticated model for the formation and evolution of comet dust trails. For Comet SW3, he used numerical simulations, and they were inputted into the computer, and he used 2 million particle ejections. And he considered ejections from Comet SW3 from 1801, before we even knew about Comet SW3, before it was discovered by Schwachmann and Wachmann. Vaubollon said, well, why don't we go all the way back as far as we can go? So he went all the way back to 1801 and then moved forward to 2006. 2 million particle ejections, and the typical ejection velocity for a sand-sized particle, in this case, was 20 meters per second. And Vaubollon did his simulations and calculations, reported back to Weigert and Brown and Shinge, and then they finished using the conclusion of their report. Looking at the future, no significant number of meteoroids released during the 1995 splitting is expected to encounter the Earth in 2022. Oh, darn it! Darn it. I mean, I was hoping, when I read this report in 2005, I'm saying to myself, man, that really stinks. I mean, here it is. We've got all of the material out there to make a fantastic meteor shower, maybe even a meteor storm, like the Belitz shower in the 1800s. And according to Professor Volbalyon, with his simulator, no, we're not going to see a meteor shower. Well, all of a sudden we found ourselves in a pandemic. And, I had nothing better to do. So out of curiosity, I tried to model the meteoroid stream associated with the 1995 breakup of Comet SW3 using computer software, an N-body integrator. So I took the 1995 orbital element for the Comet SW3, and then I created 19 proxies, 19 similar comets moving in similar orbits, except I kind of crushed all these proxies, the 19 proxies and the actual comet, together over about 1 million miles in space, put them all behind the comet to kind of simulate a meteor trail. And I knew that with time, from 1995 and then moving the comet around and round and round, that eventually, with each passage of the sun, the trail would get longer and longer and longer and longer. And what I was hoping would be maybe my simulator, my little dinky computer, my little PC program, would show that the comet would pass the Earth at the crossing point in 2022 and show a meteor shower, whereas Professor Volbalyon, with his sophisticated computer program, would not, right? All right, so nothing ventured, nothing gained. Here is how the view in my simulator looks. Here's Mercury right here. Here's the Sun. Here's Venus. This is our orbit, the orbit of the Earth. And notice here, this is the orbit of Comet SW3. And there's the interaction point. There's the point where the comet orbit and our orbit come virtually close together, right there. And so what I was hoping for would be the Earth gets to this point at the same time that the comet or its trail of debris gets there, and we'd see a meteor shower. Start the simulator, and away we go. There you go, see the planets. Here comes the Earth. Here we come around in our orbit. We're approaching that intersection point. Here it is. There it is. Boom! There we are. And where's the comet? And where's its trail of debris? It's nowhere to be found. Bacha galoop! Volbalyon was right. No, and now after we leave that intersection point, look what comes along in August. Long after we pass that intersection point, here comes the comet, and here comes its trail of debris. So the calculations by the Frenchman was right. There will be no meteor shower. And that was that. Except I got to thinking after a little bit. I said, wait a minute. Hold on just a moment here for a moment. I mean, Professor Volbalyon was just making the assumption that this is your typical situation, that the comet comes near the sun, releases material, the material goes out behind it, trails behind it, and if we happen to be in the right spot, we'll see a meteor shower. If not, we don't. But you know what? This is not a normal circumstance. The comet broke up, for goodness sake, in 1995 into 4 pieces, and it continues to break up to this day. So in the physical breakup of a comet nucleus, we just can't assume that its constituent particles are chiefly dust and sand grain size. Indeed, I would think, don't you think, if a comet were to break up, that there are going to be pieces out there that are bigger than pebbles or grains of sand or dust? There's got to be. There's got to be pieces much larger. Maybe large nugget-shaped pebbles, even rocks the size of walnuts or ping pong balls. Well, something like this, big pebbles or bigger pieces like, again, walnuts or ping pong ball size or even bigger than that. Now, how large particles are spatially distributed depends in part on the spin of the comet's nucleus. Everything in the solar system spins. Everything. Planets spin and comets spin. So you see the rotation of the comet nucleus here. And it depends on the spin of the comet nucleus and the location of outgassing materials on the comet's nucleus, on the comet's surface. As the nucleus is heated up by sunlight, bits of dust and gas come loose and spread outward. The pressure of the sun's light helps to force these particles back behind the comet. Now, the idea that light has push or pressure might sound strange to all of you. Now, if you hold your hand up to an electric light, Or if you stand out in the sunlight and hold your hand up to the sun, you can't feel light pressing on it. But nevertheless, light does have pressure. It's only noticeable, though, when the light becomes extremely strong, as it is near the sun, and only affects very small particles, molecules of gas, dust, sand grains. We call this solar radiation pressure. Small particles are pushed away more rapidly by solar radiation pressure regardless of the direction that they leave the nucleus. And the pressure, this pressure of sunlight, helps to force such dust particles to a position trailing behind the comet. But if you have particles out there that are bigger than grains of sand, large pebbles, large pieces, nugget size, golf ball size, walnut size, those are greatly unaffected by solar radiation. It's like the big bad wolf. You remember the big bad wolf in the Three Little Pigs? He blew down the straw house. He blew down the stick house. But when he tried to blow down the brick house, huffed and puffed, the poof, 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 poof. No matter what he did, the brick house wasn't going anywhere. What I'm telling all of you is that those big particles, those nugget size, those walnut size, those golf ball size pieces that are out there, solar radiation pressure can blow and blow and blow on those as much as possible. They ain't going nowhere. They're not going behind the comet. If anything, they may very well be out in front of the comet. And that is the key to my argument. In a normal case, the smaller the particle, the more rapidly it can be ejected out into space from a comet. 20, 25, maybe even 30 meters per second. The larger the particle, the more massive it is, the slower the ejection speed, 10 or 15 meters per second. But this is not a normal case. I said when I was reading the 2005 paper by those 3 Canadian astronomers and reading about the calculations done by Professor Vaubaillon, I said, no, this is not a normal case. This was the physical breakup of a comet nucleus. So when SW3 fragmented, particles of all sizes were ejected at not just slow speed, but high speeds. Even the big particles, and even the big particles ending up now not behind the comet, but in front of the comet. And you remember, those of you of a certain age, when there used to be advertisements on radio and television about cigarettes? I'm really going back. I'm going back like a half a century. But do you remember there was one cigarette? I think it was Winston. Remember their credo? It's what's up front that counts. Well, I'll tell you right now, with this story about a possible meteor shower, it is what's up front that counts. It's what's up front in front of the comet. If there are any particles in front of the comet, they could possibly intercept the orbit of the Earth in this month of May of 2022. So now, this is what I did. I went back to my simulator, and this time I loaded up used the same methodology. But this time I adjusted the comet proxies forward toward the sun and started the simulator again. And away we go. And here's the Earth coming around toward that intersection point. But look, here is the particles, the trail of debris spread out ahead of the comet. And in fact, the Earth here in this simulation on the 28th of May ended up somewhere between proxy 12 and proxy 13. So now I have a section of this long trail of debris which conceivably the Earth would intercept. All right? Then I went back and I said, okay, now that I have that, I recalculated the orbital elements for proxy number 12 and proxy number 13, and then I stuck another 18 comets in between, or 18 comet samples. What I was trying to do was I was trying to get, again, an idea of the segment, that one segment of the comet trail left behind by Comet SW3, and how the Earth would interact with that particular segment. So here we go. Here we go with the Earth moving, and here's that segment. There are those 20 comet proxies representing that segment of the comet trail. And there is the intersection point, and here we go. And it looks like we indeed interact with 5 out of the 20 proxies right there. And in fact, after doing this, I came up with May 29, 12.74 UT. UT is another way of saying Greenwich Mean Time. UT is Universal Time. But I don't have the greatest, you know, program in the world. Certainly nothing to compare with the one that Professor Volbalyan or some of the other comet and meteor experts use. So there's a margin of error here of about a day and a half. So basically, anytime from the 28th of May till the 31st of May, somewhere in that time frame, I would suspect that there would be some interaction with comet debris, which could lead us to seeing a meteor shower. Well, again, since we're in the pandemic, I decided, okay, I have nothing better to do. So I spent about 11 months doing research, and I ended up writing a technical paper of my own. And then, after sipping a little bit more of Poland spring water here, when you write an article or when you write a technical paper, and then you put it up for possible publication in one of the technical journals, the paper has to be vetted by either a person or knowledgeable persons in the field that you're writing about. In this case, my paper went to David Asher, who is a very well-known and highly respected meteor calculator. And he looked at the paper, made a few corrections here and there, and he said, you know, I think this is a heck of a great paper. And certainly it is well worth being published. And the paper was published in the Journal of the Royal Astronomical Society of Canada. I've not had too many papers published in my lifetime, but I'm most proud of this. And the paper asked the question, will comet Schwarzmann-Wachmann 3 produce a meteor outburst in 2022? Well, when you publish a paper like this, it's seen by other people, other academicians from around the world, in fact. And in fact, there were two separate groups of people, two separate teams, one in Germany, Hartwig Luthern, Rainier Alt, and Michael Jaeger, and a team from Japan, Sean Hori, Jonichi Watanabe, and Makayo Sato. Now I got to tell you, Sato and Luthern, they're right up there with Volbalyan in terms of forecasting and predicting meteor showers. And what the two teams did was they said, hey, you know, this might be interesting to consider. Maybe, just maybe, this guy Rao has something, you know, that's worth investigating. What would happen if instead of particles trail behind the comet, what if we can assume that they're forward of the comet? And so they did their own set of calculations. And I got to tell you, this really blows my mind. Both of them, working independent of each other, came up with May 31.206 UT. That translates to May 31st at 12:57 a.m. Eastern Daylight Time. That is next Monday night, Tuesday morning. Now, next Monday is the 30th of May. That is Memorial Day. But after midnight, we automatically go to Tuesday, the following day. So this is Tuesday morning, 12:57 a.m. EDT, May 31st. That is when we would be passing closest to the center of this stream of material left by Comet SW3. What blows my mind is that when the German team issued their prediction and the Japanese team entered their prediction, they were both within 4 minutes of each other. 4 minutes and a fraction in terms of astronomical units of the position relative to the Earth's orbit and the orbit of the comet. So, you know, you could believe what I came up with, but it was over a span from the 28th to the 31st, and not very accurate in that sense. Or you can go with these guys. These are the A1 experts who are saying that it will be within a few minutes of 12:57 a.m. next Monday night that we will be passing closest. But as interesting as this was, the thing that really got me happy, if you will, was when this gentleman came out with a new study. This is, I'm not going to say he was my nemesis. He was the guy who, if you remember back in 2005 with his super duper highly regarded computer simulator, this is Jeremy Volbalyan, who earlier in this century, back in the early 2000s, he was working with NASA and also at Caltech. He's back in France now, but he saw what the Germans and the Japanese did, and he read my paper. He read my paper. And he went back and did some adjusting with his computer program, and then he wrote a short study of his own. And this is what he wrote. In 2021, Joe Rao published a study showing that if meteoroids are ejected at higher velocity, they will definitely cause a meteor outburst. And Rao also explored the influence of the change of the comet orbital elements. In this short study, we confirm Joe Rao's findings and go slightly further, exploring the conditions that make the shower possible. My goodness! I wrote an email to Professor Dr. Valbayon, and I said, "Merci beaucoup. Thank you. Thank you." Oh, my goodness. I lost 2 buttons. My stomach was, my chest was expanded out. So here was one of the A1 calculators of meteor showers saying that he had changed his mind, and he changed it based upon something that I had written. Little old me with my little old computer program. So we now know that there were particles that were shot out in all directions at relatively high speeds, and Dr. Valbayon said, yes, even the big pieces may have been shot out or ejected at a high enough speed to place them in front of or forward of the comet, and yes, if that be the case, a meteor shower certainly is possible next Monday night. Now the big question. Here's the $64,000 question. What are we going to see next Monday night? How many meteors are we going to see? Is it going to be worth my while to maybe, step outside just after midnight and take a look and see if there's going to be any significant numbers of shooting stars? Well, interestingly, 5 years ago, in 2017, the Earth came close to passing by some debris that was shed by this comet, Comet SW3, and it was shed back in 1941. 1941. We didn't even hit the sweet spot. Consider this oval here, the area where all the good stuff is, where the most of the debris that was shed in 1941 happens to be. We passed 102,300 miles away from the center of this zone right here. And people were saying, we're not going to see anything. We're much too far out away from the debris that was shed in 1941, so we're probably not going to see much of anything here. And yet, on May 30th, 31st, cameras for the All-Sky Meteor Surveillance Program in California caught meteors coming at the rate of 5 per hour. So, there were meteors, even at that great distance. Now, here we are 5 years later. Now it's 2022. And look at this. Now the Earth is getting ready to move through the zone of the material that was shed by the comet in 1995. And we are going to be about 35,000 miles away from the center of this zone. And we're physically going to pass through the sweet spot, so to speak, the part of the comet where the greatest amount of material is. So that's good. That's good news. But how much is that going to give rise to? Well, we're about 3 times closer. So instead of 5 per hour, maybe we'll see 14 per hour this year, next Monday night. Yeah, that's depending upon if the amount of material is the same shed in 1941, that's probably what we would see. But 2 things have to be considered. Number 1, in 2017, 5 years ago, we interacted with material from 1941 that traveled 14 times around the sun. So those meteoroids had dispersed quite a bit from the time they first left SW3 in 1941 until they reached the Earth in 2017. This year, we're going to be encountering material that was shed in 1995. That was 27 years ago. And that's only traveled around the sun 5 times, not 14. So the debris in this zone right here is going to be probably much closer together. But now here is the question. How much more concentrated is the stuff in here compared to 1941? All right? Well, in 1941, we got 5 meteors per hour out of this. Now we're a little closer to the stream of debris for 1995. So typically we would get 14. But again, how much more concentrated? Remember, this area, this zone, is from material that was shed after the comet broke up. Remember what I said at the very beginning? The reason the comet got so very bright was because of a tremendous expulsion of material, a tremendous amount of dust and other stuff that got blown out into space. How much more concentrated is the material in here compared to 1941? Well, why don't we say 10 times more? Well, if it's 10 times more, 10 times 14, that would give us 140. 140 meteors per hour. Wow, that's quite an outburst of material. I mean, can you imagine if you step outside, midnight, 1 o'clock in the morning next Monday night, you step outside, look up, you're seeing meteors, whizzing across your line of sight at the rate of, 2 per minute. That's a pretty darn good meteor display. I certainly would be willing to step outside and look for something like that next week. Now, you're probably saying to yourself right now, where does he come into this? If you watch TV and you watch PBS, you know who this guy is. This guy is Bob Ross. Bob Ross creates masterpieces. He creates on canvas paintings in 30 minutes. He has a show called The Joy of Painting. It's a wonderful show, and I enjoy watching it. Actually, I watch Bob Ross for only one reason. He has such a soothing voice. If you listen to this guy for about 5 or 10 minutes, he'll put you right down. He'll put you to sleep in less than 10 minutes. But I watch him also for the wonderful creations that he does on canvas. And when he halfway through or 3/4 of the way through a painting, Bob Ross usually says something. And what he says is a 3-word mantra: let's get crazy. And when he says that, right after he says let's get crazy, he immediately creates he puts trees down and mountains and cabins and everything. He gets crazy in the final few minutes of the show by putting all sorts of stuff on the painting. I love that mantra, that 3-word mantra for this talk. Let's get crazy. Remember what I just said? Imagine if the concentration of material is 10 times more in 1995 as opposed to 1941, and we would get like 140 meteors per hour. Let's get crazy. Let's consider, instead of 10 times more concentrated, why do we consider 100 times more concentrated than what we had in 1941 and what we saw in 2017? So instead of 14 per hour, 14 times 100, that would give us 1,400 meteors an hour. That's not a meteor shower. It's not a meteor outburst. That would be a meteor storm. And the unofficial definition of a meteor storm is 1,000 meteors per hour. Is it possible that we might have a meteor storm next Monday night? Well, if the material is indeed in front of the comet, and if it's 100 times more than what we saw 5 years ago when we encountered the debris stream from 1941. Remember, again, this is material that was all spewed out in the aftermath of a comet fragmenting, breaking up. The comet, as I said earlier, was literally cracked open, and all of this stuff came flying out. Is it possible that we might see something like that next week? Well, let me put it this way. I don't think we can take that possibility off the table. It certainly is a possibility. Now, look carefully at this diagram. It is important. This diagram shows the Earth moving through space from left to right in its orbit around the sun. Note that the path of the Leonid meteors, some of you know the Leonids, they come along every year in November. They are an annual meteor swarm. In many years, they don't amount to all that much, but about every 33 years or so, we can get a major meteor shower or even a storm from them. But whether they come in small numbers or large numbers, look at the way the meteors are hitting the Earth. They are moving in space in the almost opposite direction compared to the Earth. They're moving head on into the Earth, moving at an ultra-fast speed through our atmosphere at 72 kilometers a second. That's 45 miles a second. And atmospheric friction releases the kinetic energy of the object in a short-lived flash of light.
What?
The energy released per gram of the meteoroid's weight far exceeds the energy efficiency of the most powerful man-made explosives. So one thing is for
Might be
certain,
having
when
a
you're looking for a Leonid,
meteor storm Monday night.
we have somebody who's talking.
Yes.
Could you please mute that person? I have somebody who's talking in the background. As I was saying, because of the fact that the Leonid meteors strike the Earth head on and they're moving at a high speed, even a Leonid the size of a pea can create a beautiful incandescent trail in the sky. So the Leonids are usually very bright and very easy to see. But now look at the meteoroids from our upcoming shower from SW3. They're moving pretty much in the same direction as the Earth. So only those particles that can catch up to us has a chance to create a visible streak. And at 16 kilometers a second, only 10 miles per second. They're moving at only a quarter as fast as the Leonids. So a proportion of those meteors may be very faint, or maybe not even visible at all. In other words, we could have 1,400 meteors an hour, but if they're all very faint or not visible at all, what's the sense? What's the use? In fact, the meteor shower that occurred with the Belid, or the comet Belid, the one that broke up in two last century, in the 19th century, those meteors were described by many observers as slow, faint, and evanescent. You ever hear that word, evanescent? I didn't. I had to go to the dictionary to find out. I had to look it up. Evanescent, faint, fleeting, transitory, vanishing. So even in the 1800s with the great Belid or Andromeda meteor storm that occurred in the wake of the breakup of Belid's comet, those meteors too were very faint. Still, not all of them were faint. There were a certain proportion that were described as exceeding first magnitude and often appearing red with trains of orange sparks. So yeah, some of these meteors were quite bright. Well, maybe the majority were faint, but some put on quite a display, quite a show. And in fact, 10 years ago, a gentleman in Ontario, his name is Pierre Martin, was out around the time when this meteor shower, the display put out by SW3 occurred, and he caught sight of a single gorgeous meteor from this display that we're hoping to see next week. He said it was magnitude -1. That was as bright as Sirius, golden yellow, and it left behind a thick wake, a thick persistent train in its wake for several seconds. Could we see one of those, or several of those, or many of those next week? I'll tell you, that would certainly make the night worthwhile if we saw a number of those kind of meteors flashing through the sky. So where do we look? Well, in 1930, when that lone Japanese observer who claimed to have seen that meteor shower of faint meteors occurred, he said he saw them from Hercules, near the star Tau in Hercules. So the meteor shower was christened the Tau Herculids. But we can't say that for the shower coming up, because if the meteors are forward and not behind the comet, they will be coming from the adjacent constellation of Boötes. We call the point in the sky where the meteors seem to radiate from the radiant. That's where they come from. And on this map of the world, this is the part of the world that will be in darkness when the meteor shower next week takes place. See that dot there? That is Baja California in Mexico. If any of you plan to be in Mexico and Baja next week, the point where the meteors are expected to radiate from will be directly over your head, very high. And these concentric circles that you see here, that's the altitude in degrees above the horizon where the radiant will be. Well, notice here in the New York area, the radiant will be between the 50-degree line and the 60-degree line. So it's going to be 55 degrees above the horizon. And you're saying to yourself now, well, that's all good and well, Joe, but I don't have a sextant here at my house. How do I know how high 55 degrees is? You do have a sextant. You know what you call it? Your hand. Take your hand, make a fist, and then hold the fist out at arm's length. Put the bottom of your fist on the horizon. The top part of your fist is 10 degrees. Okay? So, doing that, you got one fist. This is the girl now, right? One fist, two fists up, three fists, that's 30 degrees. 4 fifths, that's 40 degrees. The young man here, he's going even higher, 50, maybe 55 degrees. 5.5 fists. So again, start at the horizon and then go up 5.5 fists, that's 55 degrees. So at 1 o'clock in the morning, late next Monday night or early Tuesday morning to be precise, that's where, or that how high up, the radiant of the meteor shower is going to be. And where is that in the sky? Well, if you get confused by the constellations, don't get upset. You just look into the northwestern sky at that hour, 1 a.m. next Monday night, and look for the Big Dipper. The bowl of the Dipper here, and the handle of the Dipper. And if you follow the arc of the handle of the Big Dipper, follow the arc, it comes to this bright star here, Arcturus. Arcturus is one of the brightest and one of the most colorful stars in the sky. You cannot miss it. So all you have to do is next Monday night at 1 a.m., face due west, go 55 degrees up from the western horizon, and there's Arcturus, shining brilliantly in the constellation of Boötes. There it is, right there. And why do I point Arcturus to you? Because the apparent source of the meteors, the radiant, for goodness sake, will be just a stone's throw away to the right or to the upper right of where Arcturus is. And that's not really where you should be watching anyway. The best piece of equipment for watching a meteor shower is one of those long lawn chairs. Get it out. Certainly you might have done it this weekend when it was so hot. Maybe you went to the beach. My goodness. Take that lawn chair, spread it out, lie down in the lawn chair, and then look straight up. Look up at the sky. Keep your eye moving around. Don't stare at any one constellation. Don't stare at any one place. Just keep looking all over. And pretty soon, hopefully, you'll see a streak in the sky. Trace the streak backward. Another streak will come by, and hopefully it'll go back, after tracing it backwards, to the same direction as the same area, the same pattern of stars. A third one will come by and hopefully intersect in the same place that the first two did. And now this point of intersection is called the radiant. And that's where they're all supposedly or presumably going to be coming out from next week. And the best news of all, last week we had a total eclipse of the moon. Hope you had a chance to see it. But we can only get a total eclipse when the moon is full. 2 weeks later, the moon will be on the opposite side of its orbit at new phase. That's where it'll be next week, next Monday. It will be a new moon. Full moon, as I said, lights up the sky. Not very good when you're looking for faint objects, but when there's no moon in the sky at all, then you can see a lot more. My suggestion is to try to get to as dark an area as you can. I know it'd be very convenient for you to step outside of your house and look up and look around. But remember, a lot of these meteors may be very faint or may not be very visible at all in a bright environment. So go to as far away place, away from light pollution as you can. And since it's the Memorial Day weekend, maybe you might want to extend your weekend by an extra day. So maybe if you go up, let's say, to the Catskills or the Adirondacks or the Berkshires or the Poconos where it's nice and dark, you go there, stay an extra night. Stay there, Monday night into Tuesday morning where the skies are dark and where you can see a lot of stars. And with no moon, you should be able, hopefully, to see to a maximum extent this display. Now, as I close out this talk, I must give the disclaimer. Here it is. On TV and radio, the disclaimer is run at like top speed. No, I'm not going to do that. My disclaimer is this. I'm excited. I am excited to see what's going to happen next week, though I got to admit, I won't be holding my breath. Meteor showers are notoriously fickle, and it's possible that nothing at all will occur at the appointed time. If that be the case, but if you still manage to get to a spot where it's nice and dark and there are plenty of stars, that's your consolation prize. If you don't do that often or often enough, at least you can commune with nature under a starlit sky next Monday night, if the skies are clear. And I must also tell you that there are some scientists out there who have done their own calculations and have said, this ain't going to happen next week, including, I might add, the people at NASA. In fact, somebody who I know at NASA, William Cook, who is the head of NASA's Meteoroid Environmental Office. He's the one who has to tell all the people who have satellites in orbit around our Earth, expensive payloads, and if a meteoroid were to hit one of those satellites, that's it. Your payload goes, and all that money goes down the drain. He's the guy who has to tell everybody, turn your satellite or move the satellite every which way to try to avoid a collision. Bill Cook says, don't worry about it next week. It ain't gonna happen. The meteoroids have to move at least 50 meters a second for them to have any interaction with the Earth. So you have people like Cook and others who say nothing is going to happen. And you have others like Professor Valbalion who say, yeah, it is possible. We might have something to see. So there's no consensus. No consensus. You're just going to have to go out next week, next Monday night, and look up and see for yourself what may transpire. But if historical patterns are any guide, we are long overdue for an event such as this. Over the last couple of centuries, it seems that a new, strong shower emerges seemingly from nowhere with some frequency. Particularly noteworthy with the Lyrid meteors in 1803. We get the Lyrids every year in April. 5, 10, maybe 15 meteors per hour. No big deal, no big shower. But in 1803, apparently a thick clump of material collided with the Earth and produced a full-scale meteor storm in Richmond, Virginia. They rang the church bell. They rang the church bell at 1 in the morning to wake people up, to run outside to look, and people thought the world was coming to an end. Amazing. Surprise! Surprise! Nobody knew that was going to happen, but it happened. And how about that meteor shower with the split comet Biela? Biela is known as the Biela shower in 1872. That was a surprise too. Nobody knew that was going to happen. And here's a sad story. Quick sad story. It's a quick anecdote. One of the world's foremost astronomers of the time, Camille Flammarion. He was the Carl Sagan of France in the late 19th century. And he was so important that he had an audience with the Pope. And so he left his native France. I guess he took a train, and it must have been a long, arduous trip to go from France to Italy. When he finally got to Italy, late in the afternoon, he said, boy, I'm tired, and I'm going to have a big day tomorrow. I'm going to see the Pope, and I'm going to visit my good friend at the Vatican Observatory, Father Angelo Secchi. So I'm going to just step out on my balcony. I'm going to look at this beautiful sunset that's taking place, and then I'm going to go to sleep. And that's what he did. He later said, I watched the sun go to bed, put itself to bed in a beautiful area of orange and purple and gold. And after the sun set, he went inside, and he spent that night watching the Inside the Eyelid show. He spent it asleep while this tremendous display of shooting stars occurred literally right before him. And the next day, when he visited the Vatican Observatory, and Father Secchi told him what happened the previous night, and you can imagine Flammarion. And he said to Father Secchi, he said, well, how did you find out? How did you discover this? And Father Secchi said, I was having my normal evening meal here at the observatory. And all of a sudden I heard a knock at the door. I opened up the door. And there was a person I never saw before at the doorway. And he said, excuse me, Monsignor, can you please answer me a question? And Father Secchi said, yes, my son, what would you like to know? And he said, could you tell me why the stars are falling out of their places in the sky? And Father Secchi looked up and, and for the next 3 hours, Father Secchi is watching this amazing display of meteors. And if you think that made Camille Flammarion feel bad, when he had his great audience with the Pope, what did the first thing the Pope said to him was, did you see the shower of Diana last night? So the Pope, for goodness sake, saw it. And Father Secchi saw it, and people all over Europe saw it. And one of the great astronomers of the day, Flammarion, missed it because it was a surprise. Surprise! And before he passed in 1910, Flammarion wrote in his memoir, I will never, ever measure the disappointment of not seeing this great display of shooting stars that night. But he missed it. And then in 1933, again, another surprise, the comet Giacobini-Zinner. We passed through the trail of that comet. And again, a surprise, a storm of shooting stars. People in Portugal, people in Spain, people in Ireland falling to their knees because they weren't expecting this. And indeed, they thought, like the folks in the 1800s with Comet Biela, or in 1803 with the Lyrid shower, they thought the world was coming to an end. So I close tonight by saying to all of you, we haven't had a surprise meteor shower pop up in quite some time. Maybe this is the shot. Maybe this is our chance. Maybe. No certainty, but maybe. We might see something next week that could be spectacular. I'll be outside watching. The big question is now to all of you is, will you? And that's it. And I hope that all of you get a chance to see something that amounts to something next week. As the gentleman who used to be on television, maybe you remember the Star Hustler many years ago on PBS, he used to always finish his show with, keep looking up. Well, that's what I would say to all of you. Keep looking up, look up next week, and let's hope that we will see something of interest out of this meteor shower. I thank you again for sitting back and listening to me blitter away for about an hour and 15 minutes. Thank you. If anybody has any questions, you can unmute yourself, and I'll try to answer them as best I can.
Yeah, Jody, you copy me? This is Jay Buscemi.
Yes, Jay.
Oh, okay. I'm a ham radio operator, and you probably know we use meteors all the time, bounce VHF signals off them, and you get signals out to 2,000–3,000 miles. So we're looking forward to this. A question, you said looking in the northwest sky, as a help to what direction we point our antennas, we usually would point them in perpendicular to the path of the meteor trail, the apparent path.
Right.
So should I be looking at the meteor trails going from northwest to southeast, and therefore aim an antenna to the southwest?
I would think that would be the case. You have it perpendicular.
Yeah.
Yeah. In fact, I did it. If you check space.com, I write articles for space.com, and believe it or not, in the next few days, I'm not sure, probably around the 25th or 26th, just keep checking space.com later this week or this weekend. I did an article touching upon this very subject. I did it for people who might want to try listening to their FM radios. And in the same way, I might add, in the same way that FM radio, that we have problems here because of light pollution. There's just no place around that you could find a really dark sky. Unfortunately, especially in the highly populated Northeast, virtually every spot on the FM dial, because what you need to do is you have to find, I'm preaching to the choir here, you want to find a clear spot on the FM dial where there's no radio station so that you could hope to hear the signal from a distant FM station bounced over to you for a few seconds on that open frequency. I suggested in that piece that I wrote, try below 91.1 megahertz, because that's where the college stations are, not the big powerful like CBS FM 101, and maybe you might be able to find one or two spots, open spots on the dial where you'd be able to listen and monitor, and maybe be able to hear a distant station suddenly blare in as the ionization trail serves as a reflector and bounces that signal off of that trail and back over to you for as long as the trail is ionizing the atmosphere up in the sky.
Yeah, we use the 50 megahertz band and the 144 megahertz band primarily for meteor scattering.
2 meters, right?
6 meters and 2 meters, yeah.
Right.
Another question, if I might. Do you have any guess as to how long there would be a concentration of meteors? I mean, should I be looking from? Well, of course, I'm looking at it not from the visual standpoint, but from the use of the trails for the radio. I'm going to start looking on the 28th, because I guess just about every evening, as most of the meteor stuff that you see normally, it builds up rather slowly and it falls off quickly after the peak. Do you expect that to be pretty much the same here, Joe?
if this is anything like any of the famous storms, meteor storms that we've seen with the Leonid shower,
Yeah.
or the other display, the Jacobenid shower in 1946, the first meteor display, I might add, that was observed using radio techniques.
Mhm.
If it's anything like that, this is going to be very quick. I'll give you some idea. In 1969, I caught a brief Leonid surge or an outburst, and what happened was I was seeing like nothing, not even a stray forerunner at 1 o'clock and 2 o'clock. And then all of a sudden, at 3 o'clock, it was as if somebody had opened up a spigot, and I started seeing faint meteors coming at the rate of 2 and 3 a minute. And it reached a peak at about 4 a.m., and then at 4:30, all of a sudden, again, as if somebody turned the spigot now the other way,
Gone.
everything just stopped. It stopped. So if it's 1 a.m. for us next week, Eastern Daylight Time, I would not expect to see or hear much of anything before, let's say, 11 p.m. or maybe even midnight, and then at 1 o'clock the peak, and maybe it'll last till about 2 or 3, but then after that, it shuts off again. So these are one of those situations where the Earth whizzes through this area, this concentrated area of material, in a relatively short interval of time. And so if there's anything to be heard or seen, it's only going to last probably for just a few hours.
Yeah. Well, of course, from a radio standpoint, we can use meteors one every 4 or 5 minutes because the data rate that we're sending, we're not talking using the voice, we're using high-speed data. And we can decode stuff with the meteor bursts as little as 100 milliseconds. So I'm going to start early that night for sure with a number of people out west and see how we can do it.
Well, we'll see. Let's hope that there is something to listen to and to see on Monday night. As I said,
sure.
there are, and I just had an email yesterday sent to me by a very well-known Comet expert in Great Britain, and I asked him flat out. I said, "What do you think? Do you think we have enough material in front of the comet to result in some kind of a meteor display?" And he said, quite frankly, I don't think it's going to be possible. He thinks that the material, the big pieces, are going to be lifted off the comet nucleus too slowly for them to migrate far enough forward to allow us to see anything. So, but again, there is no consensus. There are people who I have very high regard, Professor Valbalyan, for example, and another person in Russia. This gentleman's name is Mikhail Maslov, and I've had a number of correspondences with him over the years, and he is a very good, very reputable meteor forecaster. And the last I got from him on this particular display was he thinks that you have to take a certain number, like maybe 100 or 500 an hour. He said, that's what I would expect in a normal situation, but then he said we have to raise it by an order of 10 because it's a comet that has broken into many pieces, and he's suggesting that we might see as many as 10,000 to 100,000 an hour. Now, I would love to go and ask him, what do you think now? I mean, now we're right up there, but unfortunately, sadly, with what's going on in Russia and with the Ukraine and whatever else, there's no way in the world that if I send an email message to him now that I would expect to get a response back. And I wouldn't even want to try to send anything to anybody in Russia right now, because you don't know who, why is this person sending something to Russia? Maybe he's sending a secret code or secret message, but I don't want anybody to start investigating me. So it's sad, but that's the way, that's the world that we live in. But again, Mikhail Maslov, M-A-S-L-O-V, you can look him up probably on Wikipedia, or maybe you could do a Google search, because he's written some very good papers on the subject, and he's highly regarded. He thinks we're going to be seeing a big display next week. Others say no. All you have to do is go out, and we'll see what happens next Monday night. It's a crapshoot, but let's all go outside, hope for clear weather, and see what's there to be seen.
Thank you, Joe. Great talk.
Okay, Jay, thank you.
Joe?
Yes.
Hey, my name is Steven. You were talking about seeing like turning a spigot on. And I witnessed the 1966 Leonid storm.
Oh,
from the
Oh,
southwest. I'm one of those who did see it, and it was going along at about 100 an hour, which was great for the Leonids. And was laying on my back, out in the desert, and all of a sudden it went from 100 an hour to within a few minutes it was 1,000 a minute,
yeah.
and and then for about a 15-minute period it was more like 3 or 4 thousand a minute, approaching that quarter of a
Oh,
million an hour. And it
God.
was it was so intense that you felt as though you had to raise your arm to shield your eyes, and then
Yeah.
pull it back down because they're way up there. But it was amazing. It was like turning on a spigot and then turning it off. And
One of
so
my mentors, two of my mentors, back in 1966 when the Hayden Planetarium, and this is before the Hayden Planetarium, before the Disneyfication of the now great Hayden Planetarium, where nowadays you go and you see a show for 20 minutes and it's a lot of special effects, but you come out saying like, all right, that was fun, but what did I learn? Back in the day, back in the 60s, when there were real live people giving sky shows and giving sky information, we had, the Hayden Planetarium held a meteor watch for that meteor shower, the Leonids of 1966, at the Sheep Meadow in Central Park. It was completely overcast here in New York.
uh,
And Dr. Tom Nicholson, who was then the director of the planetarium, 10,000 people showed up at midnight at Central Park to see this meteor shower. And
wow.
here he is talking from a sound truck. And he said, well, the one thing that you have to do when you go out to look for meteors is to pick a clear night. And like half the people booed, the other half, laughed and cheered. It was amazing. And Dr. Ken Franklin, the co-discoverer of radio emissions from Jupiter, was in an aircraft above all of the schmutz. And he had suggested in the New York Times earlier that day that we would have a massive meteor shower. The only thing is that Dr. Franklin, he was up there for like 3 hours, 3 o'clock, 4 o'clock, 5 o'clock. And at 5 a.m., he finally said, well, I guess we're not going to see it. It's not going to happen this year. And he told the plane to go back to LaGuardia Airport. If he had only stayed for 1 more hour, that's when what you just said, when the meteors went from 100 an hour to 1,000 a minute or something like that. Unfortunately, they landed the plane and went back under the schmutz and totally missed out on seeing that amazing display, which was coinciding with sunrise here in the east. And for all of those years, I was out there with my grandfather, as Susan Harder mentioned. My grandfather brought me into astronomy, and we had seen at the planetarium a few days before another great person, Dr. Fred Hess, the greatest orator of all in planetariums. I once told Fred he was the Joe DiMaggio of planetarium lecturers. He was the greatest living planetarium lecturer, and he had me wired. And he was a great storyteller. Nobody could approach him. And he told everybody at the end of the show, and remember, go outside next Wednesday night and we'll see a shower of stars that could be in the hundreds, the thousands. And here I am with my grandfather underneath a completely overcast sky. And I said, but Dr. Frank Field said it was going to be clear tonight. And it turned out to be cloudy. He said it was going to be partly cloudy. And my grandfather looked down at me and he said, Joey, the partly's over. Let's go to bed.
Yeah, well, it was one of the best things I've ever seen. That's for sure.
Oh boy. Well,
Uh,
maybe can I hope for a do-over next Monday night?
well,
Wouldn't
it's
that be great?
possible. It's
Wouldn't that be
definitely
great?
possible. One other thing, when the Leonids came back in 2001, I was back in the desert and experienced another first, which was the electrophonic meteors. Have you ever heard anything about electrophonic meteors?
That's a new term to me. Is that using radio or?
Well, the Leonids, some of them, of course, they're 50 miles up. So any sound or explosion when they would burst would take a long, long time for the sound to get there. But there have been reports for hundreds of years of hearing a bacon sizzling at the same time you're seeing it. And there's a number of papers there, if you Google it, the VLF radio waves, very low frequency radio waves, are actually vibrating things nearby, like the leaves in a tree or
That's
the side
interesting.
of a building. And so there were quite a few that you actually heard the sizzling while you were seeing it in the sky.
That's
So
intriguing.
you should.
I was in Arizona for that meteor display, and he said, I only saw 60 a minute. I was somewhere just north of Benson in the southeast corner of Arizona for that, and was there with my family in 2001. So that was good.
Yeah.
It was a good display.
Yeah, it was. Yeah, I got some nice pictures.
Yep.
Yeah. Anyway,
Thanks a
you
lot.
should look that up. Electrophonic meteors.
I will look it
And,
up.
and thank you for the great talk.
Thank you.
I'll be there
Thank
on
you,
Monday.
Joe. Thanks a lot, Joe. It was wonderful. We'll be out there looking.
Okay, no promises now. As I
Yeah.
said earlier. I mean, it's just a matter of going out and keeping your fingers crossed and seeing what we're going to see, and it should be interesting. Now, I don't mean to cut this short, but tomorrow morning, my wife and I'd show you how much I'm into this. I've made plans to go out to the southwest, and my wife and I are going to take a week off. We're going to travel around Nevada and Utah and Arizona, and we're going to actually be in Arizona for this next week. Hopefully, the weather will be good for this. But I'm going to have to be up at 4 in the morning tomorrow morning to get ready to drive out to JFK to get my plane. So that having been said, I'd like to get a few hours sleep before having to make that commute. So if there are no other questions, I just want to say thank you again for listening. And all I can say is let's hope for clear weather, and let's hope that nature is in a show-off mood next Monday night.
Thank you, Joe. I think that's
Thanks, Joe.
everybody.
Thanks, Joe. Fantastic. So even the second time around. Have a
Oh,
great trip.
okay. Thank you, Lydia. Thank you. Thank you so much. One of my cohorts at the planetarium, at the Hayden
Hi,
Planetarium.
Lydia. Steve Byer here,
Hi,
too.
Steve. How are you? Oh my God,
Wonderful.
long time no see. Good
Yeah.
to see you.
Hiya, Joe.
Oh
Wonderful.
my God. You look like Santa Claus.
I know. That's what Neil told me when I started this, but it's coming off next week.
Oh,
Oh,
Steve, that's a riot.
okay. All right, folks. Well, nice to see you, Steve and Lydia and everybody
Thank
out
you.
there. I thank you so much. And what else can I say? Let's hope for something next week.
Absolutely. I'm
We'll
counting
be
on
out.
it.
Have a
Night,
good one,
everyone.
everybody.
Bye-bye,
Good work.
everyone.
Bye.
Bye, Steve. Bye.
Bye, Lydia Marie. Great seeing you, too.
Great to see you.
Thank you.